Now let us do some numericals from this potentiometer part. Before going into the numericals, let's see what a potentiometer does. So a potentiometer is a device to find the EMF of a cell, electromotive force. Now the same job is done by voltmeter also. So but the problem with the voltmeter does not measure the EMF, rather it measures the terminal voltage. Means when the current flows through the circuit, then what is the voltage across the ends is measured by the voltmeter. But in potentiometer, we create such a situation that the current flow stops. So we have already learned that the maximum voltage which can be provided when the cell is in open circuit, you call it as the EMF, and the voltage which you feel across the ends when the current flows through it, you call it as terminal voltage. Almost like saying like this. See, if you are going to buy a new bike, obviously the showroom will be saying the bike which is kept in the showroom, they will be saying for 1 liter of petrol you will be getting 100 kilometers. So that is inside the showroom, still it is not on the road. So that is something like EMF. When you start driving the bike, then you won't be getting 100, you will be getting something less than that. So then you will call it as a terminal voltage. So EMF is something which is assured by the showroom, and terminal voltage or V is something which you feel when you are driving the bike. The same logic, when the circuit is open, the maximum the potential difference which the cell can provide, when the cell is in open, you call it as the EMF, and when the current flows through the circuit, then you measure the potential difference, you call it as the terminal voltage. Now coming back to the potentiometer circuit, how it works. See, assume there is a cell which is connected to a 1 meter long wire AB, and you are using a voltmeter to find out each values when you keep the voltmeter connected to a jockey, and you are taking that jockey over this wire. So each point J1, J2, J3, you go on moving that jockey over on that wire, and you find the voltage actually value differs. And when the jockey is at the extreme end, you get a value which is similar to what is being provided by the cell. So it means as you move across the length of the wire, the potential difference varies. Now this differing potential, that is the potential difference per unit length, is what you mean by the potential gradient. How much it varies per unit length is what is given by the potential gradient. So if I am using a galvanometer which is connected to a secondary cell, and I am getting a balancing length, something where some assume this is 1 meter long, so I am getting somewhere at the 70 centimeters. It means that 70 centimeters is having a particular value for the potential difference, which is equal to potential gradient, that is potential difference per unit length, multiplied by the 70 centimeters. So the voltage across this point and this point C is equal to the potential gradient multiplied by the 70 centimeters, means that much potential is between A and C. Now how does it becomes, or how you can say that it is equal to the EMF of the cell? See, what is actually happening is, assume an arrangement like a potentiometer circuit will be something like this. You will be having a meter long wire, 1 meter, 5 meter, 10 meters across, and a primary circuit is there with an EMF whose value is known to you. Let it be 2 volt. Now you are connecting a cell whose EMF you want to find out, and it is the other end is connected to a galvanometer, then to a jockey. Now you move this jockey across the length of the wire. So what will happen is the galvanometer needle will show deflection to both sides, either to that side or this side, depending upon which direction the current is flowing. Now if you imagine something like this, assume this is instead of battery, assume that is a water pump, and through this some water is flowing at a particular speed. And you have another pump here who initially assume its power is not that much as being provided by the first pump. So what will happen is this water will try to enter the main line, but the force in the main line is much more compared to this water force. So that water will enter this that water will try to enter this small pipe, or this water won't be able to enter the main pipe because that force is much more. And if you sometimes it may be in the opposite way also, that the power of this second pump is more than what is being provided. So what will happen? So this water can enter the main pump, and a point will be reached where the power between the water which is flowing to the main pipe is almost equal to the power of water which tries to enter this main pipe. So at that moment you can imagine, assume this is a meter, at that moment you can imagine the meter does not allow either the water to enter or the water to move out of this. So similarly you can think about the potentiometer. So initially a current will be flowing to the main circuit. You are finding out some length at which the galvanometer is showing null deflection. At that point, no current flows through the galvanometer, because neither the current from the main line enters this, neither the current from this unknown source moves into the wire AB. So the galvanometer shows zero deflection. So in other words, I can say the potential between the A and the balancing point, assume that point is C. The whatever be the pressure across this AC is same as that of the EMF of the cell, because that is why the galvanometer is not showing any deflection, because neither that water enters nor this water is able to enter the main pipe. So that is how you find the unknown EMF, by knowing the null point where neither current flows into the cell or out of the cell. So the EMF of the cell can be equated equal to the potential gradient, means for each length of the wire, for a unit length of the wire, how much the potential varies. So let I be the current flowing, let R be the resistance per unit length, then this becomes the potential gradient multiplied by how much it has been balanced length, so 70 centimeter in this case. So this gives the unknown EMF. Hope you understood the logic.